Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is going to be another in my practice session series about the Red Hat Certified Specialist in Containers exam EX188. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching who hasn't subscribed to click the subscribe button and ring the bell when you do, so you can be notified of when new content comes out. And if you enjoy the video, make sure you click like. One thing I want to remind everyone of is that this is a practice session where I'm going through objectives and trying to describe them or try to do some exercises to practice whatever the objective has. The purpose of this is to do a self-assessment, and then at the end of the video, if I feel pretty confident about the objective, great. If not, I still have 2 weeks before I take the exam, and that gives me some time to do some refreshing if I need to. These are not intended to be training materials, nor are they intended to be tutorials, but I do try to have the information, as accurate as I can, since I myself am still learning and I'm wanting to, learn accurate information. One other thing to keep in mind is I don't think this exam is necessarily tied to a particular version of Red Hat Enterprise Linux. I will be working out of RHEL 8 for all of this, and I think I read somewhere that as of right now the exam is based on RHEL 8, but I'm not 100% sure. I say that because you might find this video far in the future. It's currently March 2024, and just keep in mind, if you're using my video just to get some ideas of how to practice, objectives might be different if the exam still exists. So the objectives in this video are going to be the last in the implement images using Podman section. I'm going to be focusing on the understanding container volume, mount host directory as data volume, and understanding security permissions and requirements, and lifecycle and cleanup requirements. So I debated a bit about this video because in the training that I've done and the examples that I've studied and such, these 4 things weren't explicitly covered in some of my training, and so this is definitely I'm going to go and say this is something that I want to dive in more between now and 2 weeks from now when I take the exam. But I figured I'd do the video and show kind of how I would try to discover the meaning of whatever these objectives are if it's not perfectly clear, and you might find the approach useful as well. So this is about persisting storage. It's because usually our containers, the file system on the container is different than good old XFS and the ext4 and all the other file systems that we know and love. It's basically it's a file system built off of layers, and I can't give you a lot of real technical details about it because frankly I don't know them. I have kind of a functional understanding, which I think is what's needed for this particular exam. And like the very topmost layer is a writable one, but it is not something that's designed to be persisted for a long time. So you can do a couple of different ways of persisting storage. You can do bind mount that I'm familiar with, which it's very much like how you would mount file systems normally. There is a directory or a file on your container host file system that is presented to the container, and it interacts, and that's how data persists. It's stored on your file system. And then you have a volume which you can make, which is also living on the file system, but the interaction with the container, to the best of my knowledge, is much more native. It is, I think the file system presented to the container is a part of the mechanism that is what will be considered the normal file system for a container. And as all of the objectives in this section have focused on, this is concerning, all right, so you want to build a container image, and we need to specify about volumes. So let me go ahead and do a good old search for UBI. I think I've probably said in all my videos so far, one day I'll memorize the fully qualified image name. But until that day comes, I'll just search for it. I'm going to stay consistent with RHEL 8 here. I thought I had copied that. Let's see if I can do it from memory. It should be registry access.com UBI 8 UBI latest. We'll see if that's right. Yay, I might have memorized it. So I don't have to do the copy paste anymore. You can also do the registry.redhat.io, but you have to authenticate for that. So we have the latest UBI image. And let's see. So from what I understand about the actual volume directive, it tells your image, all right, so data that's stored in this directory in the container is going to persist on the actual file system. That's my current understanding of what that means. And that might change in the next 20-30 minutes as I'm going through this, but that's what I'm basing this off of. So what I want to do, I'm going to do container file, and we'll do from registry access.redhat.com UBI 8, right? Latest, I think is what we did. And I'm going to specify that, I'm just going to specify, well, first let me create a directory, and I'm going to run make dir, just test dir at the root. And we're going to say volume test dir. Let's see if this functions the way that I think that it will. Type Ansible. I spent all day at work working on Ansible stuff, so go figure. I get home and do my practice sessions and I'm typing Ansible. So Podman build -t, we'll call it storage test. Of course I made a mistake there, so let me get maybe I don't have it memorized as well as I thought. Oh, it's UBI 8 UBI. Okay, well, this is easy to fix. All right, so that should be pretty easy. So let's inspect this image and see what information we can glean from it as far as storage is concerned. So Podman inspect storage test, and as usual I'm going to pipe it to JQ so we get some colors to work with. All right, so those are the last couple of instructions. So the last layers of the container image. Order up dir, work dir. Remember that container image is really they are tar archives that have all of the bits, and so that is stored on the system, and this gives you an idea of where some of that stuff is stored. Overlay, that was the name of the type of file system. Let's see where we can find. All right, so volumes test dir. It's not telling us much more than that. All right, so I'm going to look at Podman volume. Actually, nothing listed here. Yeah, Podman volume ls did not return anything, which I kind of expect because I haven't explicitly made a volume to then mount inside the container. So what I'd like to do, we're going to create a container. Podman run. We're going to do -it because I want to run an interactive shell with it. Name storage test 1, and we're not going to have it delete, but we are going to persist the storage. Let's see what happens. So I have everything I need. Yeah, bin bash. Of course, I have to tell it the image to run against. That would be useful. We'll run bash. All right, so if I were to ls, we see our test here. Let's echo, here is some text, and we are going to output that to test_dir testfile.txt. All right, and I'm going to start another tab, and we're going to inspect storage test 1, this container. I'm curious to see what information that we're going to see with this inspection regarding storage. Okay, so we have a bind for test dir, and I'm willing to bet that is a volume that has been created kind of ad hoc, but we'll see. Create command, any other useful information, find that curious. The image. Yep, so this is a mount. Okay, so that is where this kind of makes sense. See, when I first learned about the volumes, you would do, Podman volume create, and you make your volume. And then when you run your container, you do -- volume and have volume name, colon, the destination directory on the container that you're wanting to mount it at. And that looks like what has happened here. We have volume, we have this particular, the name of the volume, which is I don't know if this is a UUID or GUID. This is where it's actually on the file system. That's where it's mounted in the container. All right, that's kind of what I expected to see there. All right, cool. Now, one thing just to make sure, no test year was made on the file system, because that's what we're mounting inside here. We have made that, so let's do Podman volume ls. All right, so it actually made a volume, and its volume name, it's obviously not a friendly name, it's just auto-generated. And that file should be on our file system. Let's see if we can go find it. Where was that at? Yeah, I could do Podman inspect volume. Let's do that. Podman volume inspect. All right, so this is where it is. Let's ls this directory. There's our test file. I'm going to do ls-lz on the directory. So I think this gets into a little bit of the security bit, and this is something that I'll talk about when I talk about bind mounts. Owned by my user account, which kind of makes sense because this container is going to be running. Actually, we can do podman top. Should be running as me because I'm pretty sure it's the root user on the container. What's that? Storage test, and we want H user and user. Yeah, so it's root running as user 1000. I know that my user ID is 1000 on the system, so that makes sense as far as this SC Linux context is important. Otherwise, without that container _file_t context, the container would not be able to read anything, let alone write to it like we did. And we can we can. We'll cat this out just to show that, yep, that's our storage. And here is some text. Okay, so I'm happy with that. Now what I want to do, we're going to exit Podman PS. Container's not there because it's no longer running. PSA exit 0, because remember the command was bin bash that I had run. Now I'm curious to see if that volume is still going to be there. Podman volume ls, and it is. All right, so that makes sense because we have this persistent storage. Let us inspect the container again. Podman inspect storage test 1, and it should have a configuration. Yeah, so it's going to have a bind, and that's that volume, and that's bound to test year with, some kind of read write and other. Yeah, that's what we expect. The image itself does not specify the name of the volume because it looks like that is made at container runtime. So let's run another container. And we'll do podman run. Let's see. We should be able to. Oh, this will work. All right. So, no, because that's going to. I was going to do echo whatever, but I think that's going to output to a file that is on our file system. I don't want to do that. So we'll do IT again, name storage test 2, and we'll use the storage test image, bin bash again, and we'll do the same echo. Here is the second file. We will do test year test file 2.txt. All right, exit that. let's look at our volumes. So we now have 2 volumes for that. Cool. And I'm sure if I were to inspect this container, that it would have a mount for this particular volume for the for test year. And I'm willing to bet I could do, or to do Podman start storage. I think I can do this. Storage test 1. And we'll do cat test year test file 1.txt. Let's see what happens. Well, you see I don't use Podman start that much. I'm usually just Podman run and have the container work. So let's take a look at man for Podman start. Wasn't expecting to blink on this. Oh, I might have to do Podman exec instead, because this isn't going to. Let me try Podman exec against a container that's not running. I don't think this is going to work. Podman exec container, yeah, it has to be a running container, and then this container is going to immediately exit because all it's doing is just running bash. Okay, well, that plan kind of failed with what I was wanting to do. I was going to try to cat out the file, but we know that it is stored persistently. So what I said before was my understanding that the volume directive in the container file is going to basically say I want contents at this particular mount point in the container, in this case slash test year. I want that to persist on the system, and that turned out to be true. And what it did in the process was create its own volume with a wacky GUID, but that is a part of the container. You don't have to necessarily remember that volume to do stuff. So the security and permission requirements, this obviously is done in the background, but I do remember the container file T SE Linux context is important for that. I am curious, if we do a rootless container, what that will look like for permissions. So let's try that. So we're going to actually make another image. And what we're going to do is create a user. Nope, we're going to do, well, we can do this all as one command. User add good old test user 1. We are going to go and chown test user 1 for the test year volume. And now we'll look at, and we want to run as the user test user 1. And let's see what happens. So now we'll do Podman build -t. What did I call this? Storage test. We'll give it a tag of 2. All right, and now let's run another container Podman IT name storage test 3. We're using the do Podman run. That's why it's not doing tab completion. And IT does not need 2 dashes. Storage test 1. Wasn't expecting that. Oh, I did 2. That would be why. Okay, so we're here as test user, and let's echo test user's file to test dir, and we'll call it test user.txt. If we go to LSL that, we see that test user root is, and this is a normal thing. Well, it's a normal thing anyway, but I did chown. I did not specify a group owner. I just specified the user owner. All right. And while this is running, let's open another tab. Do Podman top or Podman top storage test 3 user, and we see the mapping that I've talked about in another video. And let's look at Podman volume. Made another volume here. We'll inspect this one. I couldn't begin to tell you what the other drivers were if I knew them. They're out of my head. I might try to look that up at some point, but local kind of makes sense because this volume is on your local storage. It's not like an NFS share or anything. So what I imagine you might be able to configure something like that. But we'll volume inspect and let's ls-l this directory. Oh, it's test file 2. Must have been a different, must be the one in 8. That's the volume that was made. So Podman volume inspect. Oh, I see the naming convention is, local share container storage volumes and then the name of that. So ls-l. Okay, now notice the owner here. This is that mapped subordinate UID for the user that's in the container that's mapped to my user account. That's kind of neat, and that also makes sense with how the container process and such, how it determines who owns that container process. So that's kind of nifty. Good to see that, and also just kind of good to know to keep in the back of your head. So we'll exit out of this container. That'll stop everything. And so now let's consider the cleanup requirements. So we're going to, let's see, Podman ps-a, and let's inspect storage test 1 real quick. Podman inspect storage test 1. I'm going to cheat, pipe to JQ. And grep for volume. There we go. So this is the volume that is 6 with the rest of the characters. So the question is, all right, so I'm going to delete the container. Is this volume going to persist? And my prediction is no. Let's see if we are correct. So Podman RM Podman RM storage test 1. So it gets rid of the container. Podman PSA. That's gone. Podman volume ls. It is still there. That's interesting. And that also, now that I think about it, that kind of makes sense, because if I do Podman volume create and I give myself a volume that has an easily recognizable name, that that volume is still going to persist along with its data. If we were to ls-l, this file should still be there. So the question becomes, all right, so how are we going to get rid of this? Well, we could do, volume, I think it's like Podman volume RM, but there's also a prune command. And we are going to take a look at the man page for Podman. I can't remember if prune is its own command or if it's attached to other things. I believe it is attached to other things. So Podman volume, see if my memory serves me well here. Prune. -- help. And one thing to keep in mind, when you're on the exam, you have the built-in documentation. So if you get stuck on something and you can't remember, this is -- help will often give you enough of a clue to know what's going on. So this makes sense. So what this is going to do is get rid of volumes that are currently not being used by or owned by the container. So if I were to do Podman volume prune, and I guess it'll ask you, are you sure? And it actually will prune any volume that is not currently being used by a container. So, or rather not, I think that's probably a key difference, own versus use, because technically the containers, none of the containers are using the volumes right now because all the containers are stopped. So Podman PS, see our 2 containers there still, and Podman volume ls. I'll bet that's what the lifecycle bit is talking about, as far as, all right, so you've got rid of your container, but just removing the container is not going to remove its associated volumes. I am curious. Let's do Podman RM -- help. I wonder if help, that's not going to help us much. So I'll bet -V would have also got rid of the volume if you didn't want to do that in one fell swoop. And actually, let's try that. So Podman volume ls, we have that. Let's do Podman rm storage test 2-v. All right, Podman volume ls. Yeah, all right, so that did what I expected. And anonymous volumes kind of makes sense because remember, we did not, we, to my knowledge, can't specify a volume name in the container, or in the container file as image instruction for creating the image. But we can double check real quick. Now we can do a bind mount with the run command. I might see, would that be appropriate for this? Because this is specifically talking about volume. But, and frankly, I haven't practiced doing a bind mount from a container image. And that's really kind of an interesting thing, because you would almost have to expect the builder of the image would have to know that, some directory is available to be bind mounted into the container. Since we have a little bit of time to see how the video is doing, not sure how well audio is going to keep going. 30 minutes, sometimes it starts to get choppy, or at least with I'm using the flat pack version of OBS, and I have noticed that to be true every once in a while, so maybe the audio is okay. But anyway, while we're here, let's go back to the beginning of the run mounts. So we will do --type. Type's going to be bind, and we have to have source destination. Okay, that makes sense. So let's do this. Let's make a directory in temp /make dir. What am I thinking? Temp test dir. Or actually, we'll call it test folder. All right, so we have that there. And let us go into our container file. We're not going to do this as a rootless container. We are going to make the test dir directory, and we're going to try that run mounts option. Mount. I think it was. Now, this is something I do want to practice a few more times before the exam. I want to kind of have that under my fingers, because one thing when you are taking a Red Hat exam, you don't have unlimited amount of time, and if you have to find yourself looking up everything, then that is a problem. All right, so it was type equals type, so bind, then it was source equals temp test folder, dest or just dst. Oh, you actually have to write it out. Source and destination. It's my Ansible coming through, and the destination for this is going to be test dir. Now, we're going to try something first, because I know when you do a bind mount, you usually have to have :Z at the end to set the SE Linux context on the actual host file system to where it'll be the container file T context. But let's just see what happens with this. So let's do Podman build -T storage test 3 container file. Let's just see what happens. Wasn't quite expecting that, but I guess it kind of makes sense. Oh, I see. I kind of misread that, or maybe it's not written super well in itself. So maybe it means to do this. And this would make a bit more sense. But even then, it would be like --. Well, let's see what happens. This is why you have the practice session, right? Try this kind of stuff over and over again just to see what happens. Yeah. Exit status 1. wonder if that's an SC Linux thing. I'm not going to pick at this anymore in this video. I'll do some research on my own, because I haven't, obviously, as I said, I really haven't practiced this. But as far as the letter of these objectives, I think I've covered it as far as understanding the volume directive in the container file and understanding how the permissions work if it's a rootless container, that the files and such that, and I would imagine subdirectories, and they are going to be owned by that mapped user. If it's a root container, then it'll be owned by you, most likely your user account. Dealt with the cleanup requirements as far as the prune, and I feel fairly confident with this. I don't feel confident with that mount command, so that'll be something to look at. Well, as always, I hope you found this useful with your own practice. Maybe some of my ramblings through this spark something for you to help you remember some type of fact concerning the objectives. If you did enjoy the video, make sure you do click like. Thank you to returning subscribers again for watching another video, and remember to subscribe and click the bell if you have not subscribed yet. As always, thank you for your time, and I will see you the next time.